Hello everyone, my name is Thoai. I hope everyone is doing well. Today I will present a research paper titled A Blockchain-Based Authentications and Security Mechanism for IoT. Um, and this paper is by Dongxing, Wenping Deng, Wei Ping, Thang Guy. And before we continue, we do have a 4-month old baby in the house, so please excuse of any spontaneous screaming for attention. Thank you so much for understanding. Okay, so for our agenda today, as an overview of the presentation, we will define some technologies that will be covered in this paper. Then the problem of the paper trying to solve, the technology that the paper proposed and is using, then the implementations of which the paper took, the advantages of the proposed solutions, and we will then end with the future of the technologies mentioned in this presentation. Okay, so for the introductions, I want to go over some of the technologies that's going to be mentioned in this paper. So what is the Internet of Things, or IoT? In short, it is a system of internet connected devices, all collecting and sharing data. So what is an IoT device? A device that can collect and transfer data over a wireless network with no human intervention. So due to the computer chips becoming so cheap these days and the common access to Wi-Fi, it is now possible to turn anything into a part of the Internet of Things. Some example devices that can be categorized in this is like a smart home appliances, like a stove, a refrigerator, a dishwasher. It can be in industrial robots. Could be as small as a fitness wearable, like a Fitbit or an Apple Watch. Let's see. Or it could be something as big as a self-driving truck. And we all probably have a more common device like a digital assistant, such as Alexa, Google Assistant, or Siri at home right now. So basically anything with added sensors to give them some level of intelligence. For the problem, so this paper present that there are securities issues with the traditional IoT, and that the IoT device needs strong self-protection capabilities to defend attacks from inner or outer attacks, with authentications mechanism which can secure identities of all devices on the network. So traditionally, the authentications mechanism is based on a public key infrastructure, or PKI, which has a central authority where it has a single point of failure waiting to happen. Then lastly, critical data can be tampered with or hacked by attacks without being identified. So to address the problems just mentioned, the paper proposed applying the blockchain technology which provides secure, tamper-proof, distributed ledger for IoT devices with data protections mechanism by hashing data into the blockchain. Also makes the traditional centralized network structure become a decentralized and greatly improve the security of the system, where the failure of some nodes or devices does not affect the stable operations of the system. And the also the con- the consensus algorithm to update each other node to prevent the malicious node from taking over the network and the data, so the data won't get tampered with. So before we move into the proposed method of the paper, we'll touch base on what is blockchain technology. So blockchain is a distributed database that is used to create a decentralized system where data is stored on multiple computers or servers connected by peer-to-peer network. Blockchain is an order backlink list of blocks where each block is identified by a hash generated using the SHA-256 cryptographic hash algorithm, and each block reference is the previous block. So the system creates this system creates a trustless environment. So here, trustless means the participants involved do not need to know or trust each other or a third party for the system to function. Where trust is placed in the concept rather than companies or third parties, and trust is minimized but not totally out of the equation. Blockchain is also flexible, where the failure of some nodes does not affect the operations of the system, and updating each other nodes for consensus prevent malicious nodes from taking over the network and data, where data won't get tampered with. The consensus mechanism is where it makes sure that each node stores the same data. So here are some advantages to a decentralized system. No dedicated servers for data storage, peer-to-peer system network, always available of data, higher rate of data security due to encryption, operational cost is lesser. It requires less computing power and bandwidth as well. So to continue with the proposed solution, this solution focuses on the following processes. First, the enrollment of device. Here, all devices need to complete their registrations in the blockchain before authentications. Each device generates a key pair from its own security key module. A private key is encrypted and stored locally, and a public key is stored in the blockchain ledger. And the blockchain also stores the hash value of the data in the ledger or data integrity for data integrity verifications. Second is the identity authentication. So this authenticates using register information. Let's go over an example. Let's say device A sends a connection request to a device B in the network. So first, device B searches the public key of device A in the local blockchain ledger with the ID of the device A. So if the public key of the device A is found, the public key is then used to verify the identity of the device A. Otherwise, device B searches the public key of device A in the consensus node, and if found, the device B will verify the identity of the device A. If the device A public key could not be found, then the device A has not been registered in the blockchain system. and therefore the device B will reject the connections request from A. And then lastly, the identity verification. Okay, here device will be verified for the integrity of the hash of the critical information in order to discover any potential intrusion behavior. IoT nodes will periodically send an integrity verifications request for the data to the neighboring node. If the verifications fails, then this indicates that there is a key configuration file that has been tampered with or hacked. And then a warning will be triggered. So this paper used a permission blockchain network on Raspberry Pis using the open source Hyperledger Fabric. So Hyperledger Fabric is a blockchain framework for developing blockchain-based solution. And permissions blockchain is a type of blockchain that accepts only known entities making transactions with unknown entities. Each Raspberry Pi is a node connected in a lane network where all transactions are recorded on the blockchain, like device registration, identity authentications, integrity check, and for pair key used to authenticate is generated using the cryptographical secure pseudo-random number generator because of its secure entropy source. So data structure is used Merkle key, or Merkle key, a Merkle tree or binary hash tree. So a Merkle tree is used for data structure in each block, and each block contains a summary of all the transaction in the block. In addition, it uses hashing encryption method that is also impossible to forge or steal data. Lastly, the paper uses the practical Byzantine fault tolerance as the consensus algorithm to check for the same value, the same data value, or to make sure that the same data value is reached among all the nodes on the system. So what are some main advantages of the proposed system? First, intrusion prevention of malicious nodes. With the peer-to-peer authentications method in the permission blockchain, access control layer effectively prevent malicious nodes from intruding. Next is resist distributed denial of service. Due to the decentralized nature of the system will still work even if some nodes are under attack. Next, prevention of firmware backdoor. With the use of hashing and the nature of the blockchain, any node can verify the integrity of the data and can show the firmware backdoor if there's any. And then lastly, generic nature, simplistic and low implementation costs, which makes this suitable for lightweight devices like IoT. So for the future of IoT and blockchain. So what is the future for this the technologies? Communication with different blockchain. Right now, all the devices that communicate with each other have to be on the same blockchain. There is a solution in the making, which is called a Ledger Nano, that would allow machines to communicate with different blockchains. Um, so until then, there is some limitations to this. And then hack-proofed um, immutable transactions. Again, the importance of immutable transaction where records cannot be changed once they are registered on the ledger. This makes it virtually hack-proofed. IoT with blockchain allow faster and more streamlined processes from the manufacturer to the recipient, since everyone has access to all the data with an easy and secure way to sign them. With the IoT and blockchain in the top trending technologies for 2021 in the IT industry, there is a bright future for this collaborations, and I can't wait to see what that is. So, to conclude, in this presentation, we went over the drawbacks of the traditional IoT in the identity authentications and security in centralized environment. Where this paper proposed a blockchain-based model for the IoT authentications and security. We went over the system model implementations with the Hyper-Ledger Fabric, also the proposed system advantages, and then lastly, the future of IoT and blockchain as the top trending technologies of 2021. Here are the reference I used for this presentation. And thank you so much for your time and success. No babies or harm in the production of this presentation. And have a good one.